During test runs in the Pacific, engineers recorded forces equal to more than 40 tons being absorbed in just a couple of seconds. Hidden beneath the steel deck, a maze of cables and high-pressure hydraulics stands between a safe recovery and disaster. Today, we go inside the $140 million system that can stop a modern fighter in seconds. Before we open up this machinery and what it really does for naval aviation, consider following the channel so you don't miss the next deep dive. On every carrier landing, the deck becomes a precision zone. The jet comes in at controlled speed, guided by instruments and a narrow visual path. Up top, the crew aligns signals and positions. Below, the arresting gear is already pressurized and waiting. One goal drives it all: catch the hook, tame the energy, protect the pilot. Beneath the flight deck, cables, pulleys, and hydraulic units turn raw impact into controlled slowdown. Engineers watch pressure, temperature, and piston travel in real time. Each reading shows how much stress the steel and fluid just absorbed. When anything drifts off its target band, settings are corrected. Every landing becomes data for the next touchdown. The moment a jet stops, the reset cycle starts. Technicians check the cable and send it back to its exact position. Hydraulic pressure is leveled for the next aircraft. The deck never stays idle for long. Efficiency comes from repeating this sequence of verification and adjustment over and over. The arresting system is a chain of high-strength cables, drums, pulleys, and large hydraulic cylinders. Each piece has a defined wear limit. Entire sections are swapped out before failure. That planning keeps the deck open even on busy days. Preventive maintenance is as critical as the perfect landing itself. The system has to handle jets with different weights and speeds. Settings change with aircraft type and fuel on board. Controls fine-tune how hard the hydraulics pull back. In emergencies, extra safety margins are built into the response. All of it is aimed at keeping the deck usable under heavy demand. Not every approach ends with a cable capture. When the hook misses, a bolter procedure kicks in. The pilot goes to full power and launches off the deck. The system still logs the partial impact. Those traces help refine hook height, glide path, and timing. Each bolter becomes a technical warning and a lesson. At night, the difficulty climbs. Deck lights are tuned just enough to guide the eye without blinding the pilot. The dark sea kills depth perception. In rough water, the ship moves under the glide path every second. Even then, the arresting gear has to respond with the same precision. Engineering fills in what human vision can't see. Modern arresting gear relies on digital control to match each landing's energy. Sensors track cable speed, aircraft mass, and piston stroke as they happen. Algorithms choose the ideal hydraulic response. That reduces wear and widens the safety window. The price tag is high, but so is the predictability it delivers. Long before the system goes to sea, it's hammered on land. Test sites simulate carrier landings with real jets and real cables. Engineers can force controlled failures without risking lives. The numbers they gather shape operating limits and software logic. The carrier receives gear already proven under extreme conditions. A modern arresting system can cost well over $140 million, counting design, hardware, software, and years of testing. Each safe landing justifies that investment in a few seconds. Understanding this machinery reveals the carrier as more than a symbol of power. If you want more breakdowns of how systems like this really work, hit subscribe and stay with us for the next deep dive. Not every landing begins with a healthy jet. In emergencies, the arresting gear becomes the last hard line of defense. A damaged nose gear or combat hits push load levels higher than normal. In those moments, safety margins shrink. The mission does not change. Absorb enough energy to get the pilot away home. Each arrested landing heats up internal parts and accelerates fatigue. Cables, pistons, and valves rack up load cycles. The system is built with strict limits for how far it can be pushed. Beyond those, failure risk rises fast. Tracking temperature and wear is key to keeping reliability where it needs to be. At one stage in the cruise, a close-up inspection flags a potential weak point. The gear still works, but the wear has crossed the comfort line. The team chooses to replace parts before they break. Those proactive calls come straight from continuous measurement, not guesswork. With fresh hardware installed, tempo ramps up. Multiple jets return in tight sequence, demanding fast reactions from crew and machinery. Each landing eats into the system's capacity. Even so, the deck must stay open for the air wing. Training and engineering together keep operations flowing. Even with all that control, surprises still happen. Gusts, small weight differences, and subtle trim changes can push the system toward its edge. A near miss exposes how cables, hydraulics, and human decisions intersect. These rare moments almost never make headlines, but they're logged in detail deep inside the ship. After a near incident, nothing is left to memory. Engineers replay the event value by value. Crossloads, angles, and timing are matched against older data. They pinpoint how wind and alignment drove the stress spike. New procedures follow, turning a close call into a permanent improvement. Technology alone doesn't keep the deck safe. Training drills teach the crew how to react when the cable fails, snaps, or misses. The same moves are rehearsed until they become second nature. Every sailor learns exactly where to run and where not to be. Fast, drilled reactions are part of the system. On a set schedule, the carrier heads into port for deeper work. The arresting gear is opened up far beyond what's possible at sea. Techs inspect parts that usually stay hidden. The wear patterns they see tell the story of years of landings. From there, upgrades for the next cycle are designed. Once the system is rebuilt, the ship returns to blue water. The first few traps are treated as live tests. Real-time readings are stacked against the predicted curves. Only when the match is closed do operations ramp back up. Step by step, confidence in the rebuilt system returns. With the gear validated, the ship sails into rougher weather. Forecasts call for strong winds and heavy seas ahead. Flight ops don't simply stop. Under those conditions, every landing probes the outer edge of the design. The arresting gear is about to prove itself under the worst the ocean can throw at it. As the storm builds, each approach becomes a live stress test. The ship pitches, shifting the touchdown point on every wave. The arresting gear runs at higher pressures but still inside its limits. Engineers follow every spike as it appears. Now, even a small miscalculation could cost the jet. With the wind howling, no landing is routine. System data shows the safety margin shrinking with each severe recovery. Big seas and low visibility turn the deck into a moving target. Only essential jets are cleared to come back aboard. The arresting gear becomes the last barrier between chaos and control. After the hardest traps, the system is reassessed on the fly. Logs confirm there is still capacity left, though not much. Decisions weigh technical risk against operational need. Each new recovery is cleared one by one. The arresting gear stays online, but now every move is under a microscope. As the weather window closes, one final recovery is approved in full storm conditions. The jet returns heavy and nearly out of fuel. The deck is moving and the pilot can barely see it. The gear is tuned to absorb the maximum energy allowed by its design. This single landing becomes the defining test of the entire cruise. Once that critical landing is over, the focus shifts to verifying integrity. Every key component gets checked, touched, and measured. The extreme event data is archived as a baseline for future models. Flight ops dial back while the storm fades. Pushed to the edge, the system has done exactly what it was built to do.